In this video, we'll be looking at alpha and two new concepts, beta and power. So let's say we're doing a hypothesis test and we're trying to test to see if a proportion is 30% or if it's actually greater than 30%. So we run our test, and when we do, we get a p-value. And the p-value that we get is 0.001. That is a smaller p-value. So by most instances, we should think we're going to reject our null hypothesis because our p is less than our alpha. And let's just say alpha equals 0.05. We'll use the standard alpha or standard significance level. So we believe that the proportion is indeed greater than 30%. We've proven what we set out to prove. Graphically, what this actually means is our alpha value could be this area right here at 0.05 or 5%. Our p-value is smaller than that. And based off that, the claim is that it's supposed to be 30%, so as you can see, our p-value is significantly far away from the 30%, and that's why we rejected the null hypothesis. Now, we could have always made a mistake when we were making our test. So if you remember, a type 1 error occurs when you reject the null hypothesis and you really shouldn't. So you incorrectly reject the null hypothesis. Well, in this instance, because we did indeed say that we were going to reject HO, if we were to make an error, we made a type 1 error. Now, if you look at our diagram, the chance that we make a type 1 error is actually alpha. The area that we use as a significance level is the chance of making a type 1 error. Therefore, if a type 1 error has severe consequences, you do want to use a small alpha. So let's say type 1 let's say this was having to deal with increasing death rates, and a type 1 error would be severe. I want to use a smaller alpha like 0.01 or 1%. Historically, traditionally, we always use the 0.05, and you may continue to use 0.05 despite the consequences when you're running your test. But that is one reason why you'd want to decrease alpha, to reduce the chance of a type 1 error. So the objective is to correctly reject the null hypothesis. But what is the chance that we actually do correctly reject the null hypothesis? Well, correctly rejecting the null hypothesis is something known as power. Let's say in reality the true population proportion really is 60%. We should have rejected the null hypothesis because 60% is definitely greater than 30%. What that actually means is we have this second normal curve here. And the second normal curve should be centered around 60%. Consider this a number line. 30% is definitely less than 60%. So if I take my alpha and I place it in the exact same spot on the new curve, numerically, the resulting area that I see on the secondary curve is known as power. In other words, we should have rejected the initial curve, which we did because our p-value is very small, for the second curve that has a new higher percentage. And the resulting area that is to the right, because I chose greater than, of the alpha value is known as power. But if you see, we do have a third area here. This third area is known as beta. Beta actually represents the chance that you make a type 2 error. Okay, why is that true? Remember, type 2 is when we fail to reject the null, when in reality, the null is actually false. So what does that mean? We get something in this region here that I'm highlighting in red. So we say fail to reject. Why do we fail to reject? Because our value is close to 0.3. So let's say we get 0.4. 0.4 is very close to 0.3, so we're going to fail to reject. We think the proportion really is still 30%. But reality, what's going on is actually this secondary curve. The proportion really is higher. Therefore, we made a mistake. We should have rejected when we didn't. Well, this area down here, the area in purple, actually represents the chance that we should have that we didn't reject when we really should have for the alternative, which is over here. In summary, alpha is the chance of type 1 error. It's also known as the significance level. It's what we use to reject or fail to reject a null hypothesis. If the type 1 error has severe consequences, you want to minimize alpha. Beta is the chance of a type 2 error. And power is the chance you correctly reject the null hypothesis. We'll go over the relationships between alpha, beta, and power when we're in class.